Hey guys, this is going to be a deep dive into Bloom AI. It's an open source AI. You may have heard of it before. I'm going to go into a lot of detail. Really impressive. This is really cool. Once you log in, you can access this little interface and put text in that it can complete. In this video, I have bookmarks and I also have links below with a lot more detail. With that said, let's dive right on into it. Okay, so we're going to start by taking a look at a very high level of what Bloom is. Bloom is an open source AI and it's open access. It's really, really substantial as far as the amount of data and the compute that's required to keep training it. So it's currently available on the GeneZay supercomputer, and it's basically being hosted as a data model on Bloom or on Hugging Face as Bloom. So you can actually go and access it there. You can technically download and run Bloom on your own. So you can run it locally, which is pretty cool. If you go and you read this article on it, which we are going to go into in quite a bit of detail, it actually goes into detail on exactly how to set it up. We're going to take a look at the GitHub repos and we're going to go into some of the nuances of getting that going. So I will be in this tutorial, and again, links are in the area in the description below, and also you can just jump ahead. I'm going to be going into quite a bit of detail in this. But anyway, long story short, Bloom itself is a 176 billion parameter open source AI. It's able to generate text in 46 natural languages and then 13 programming languages. And we're actually going to take a look at some programming language examples, and that's pretty interesting, as well as the different languages themselves. And then basically, it has over 100 billion parameters, and it's the first language model with over 100 billion parameters ever created. And it's been over 1,000 researchers, 70 plus countries, 250 plus institutions, including a total final run of 117 days training Bloom. So really, really impressive what this group of researchers have done. And you can see they're talking about how in this article, and this is sort of the intro blog post about it, one of the big intentions behind this is research. And the idea is to make it open as far as what the parameters are and what the training results are, so that folks can see any biases in the system based on the training data, among other things. And this is really powerful because in theory, this could help eliminate some biases and issues that folks see with big data sets, training some of the other platforms that are out there, like GPT-3, for example, and Facebook's AI, some of the Google AIs, etc. So ultimately, this is a really powerful opportunity. And they kind of jokingly talk about how if you don't have 8 A100s to play with, they're finalizing an interface that you can go play with. And this is on the Hugging Face site. I'm going to go through that and walk you through how to do that. If you're not familiar, it's really easy. All you have to do is log in with Hugging Face or register and then log in. And then you can actually play with Bloom AI. You can also test with some of the other AIs that they host and make available. And this is free in general. I mean, as you use more of it and need more compute capacity, they have options to purchase more dedicated hardware, etc. But basically, the idea is that you can get a very good sense of what it's capable of. And with that said, let's actually take a look at that right now. So one of the first examples I wanted to use was just completion of a C# set of code. So basically the idea is to take an existing set of code, which isn't perfectly written or 100% optimally written. So I just used this little snippet and grabbed it and pasted it in, and basically added this section about multiplication. And I didn't put any detail in it. And then I let Bloom complete this, and you can see that it rewrote the code. So it added a using and then it added the namespace and sort of cleaned up the way the code was written here. But it also then cleaned up the way the sum inputs and the way it was working were done. And then finally actually added the product. I called it multiply. Bloom actually called it product, which is a technically correct term. And then basically built out the code. It was interesting that it reused the sum variable that's here that we had defined earlier. So I think that's just more efficient, which makes sense. But pretty interesting that it was able to sort of extrapolate that I wanted to do a multiplication, and then it got the right name of that operation, calling it a product. So kind of cool. And it did this in perfectly valid C# from what I was able to see, which again is really impressive. This is really cool. So obviously we can go over this with different programming languages, JavaScript, obviously PHP, Java, etc. And if you're interested, I would love to share some examples from some of those other languages. Feel free to let me know in the comments section, or just, indicating that that's a language that you'd be interested by just commenting on what language would be helpful. And I'll be happy to do a deep dive into that in particular. Okay, now the other thing that I thought was pretty interesting about the language model was it actually will talk about itself. So I asked it, I said, Bloom is an incredible AI that can help with, and then it sort of went into detail. Now, the one thing that I'll point out here is there is not currently an Alexa app or a Google Play Store app or Apple app yet for Bloom AI. But if you're interested in that, one of the things that I was looking at is potentially building using the Alexa developer portal. They do have the ability to go ahead and build out a detailed skill. Let me show that really fast on my screen. So you can actually make a Bloom AI Alexa app using skills inside of Alexa. So if you wanted to do that, that would be an option. And again, if you're interested in this and you don't mind just posting a comment below, I would love to do a deep dive on this and get into detail and set something like that up. I think it would be really interesting. Okay, so anyway, if you sort of read though what it did, it basically completed the sentence that I wrote. And I just asked it for a really simple sample. You can switch to greedy mode. But again, once you log in, you can access this little interface and put text in that it can complete. You can choose different languages. You can see it lets you choose math, for example, in addition to some of these other languages. You can also give examples and sort of go through like different scenarios that it's going to choose. As you can see, the UI is kind of maybe a little frustrating there because it erased what I had, but you can see some of these different examples that it can actually complete. So here we'll just say, do a hello world in different language, Python print hello world. And now you can see it's running. Okay, so I'm going to let this keep running. It looks like it's taking quite some time to finish for some reason. I think it's probably just the interface here, the way that it's set up, but we'll see how long that takes. I'm also doing just some kind of fun examples. So here I asked it, how many Skittles fit into a 747 jet? And I asked GPT-2 the same question and got a pretty interesting response. This is Bloom that I'm asking. And it says, depends on how many I'm allowed to eat in a row. Answer, it's a variable. Or the answer is, it's a variable. And then I asked it, how many rockets has SpaceX launched? And it said, depends on how many I'm allowed to launch in a week. Answers a variable. So it's not really that great at sort of like these type of questions, but that was a pretty clever response to be able to, respond with this type of variable response, which I thought was pretty cool. If you look at its responses then to sentence completion, this was a little bit better. I said, SpaceX launches many rockets per year. In 2022, it launched, and then Bloom completed it and said about 50 rockets. SpaceX has a lot of cargo manifests. Some of its rockets can land themselves. I typed that in. And then I also typed in all of its time, SpaceX has launched a total of, and then I let Bloom fill in the rest. And it said 700 rockets. That is not a lot in general use. With improvements in digital fabrication, we expect rockets to be far cheaper and cheaper. That will be a gradual process. So I believe the number of rockets is around, and this may be wrong, but I quickly looked it up, and I believe it's around 200 or so, or less than 200 total. I could be wrong about that. I would love for anyone to correct that, but I wouldn't be surprised if technically they've done a total of 700 launches for testing and such. So this could be accurate if you include those. And obviously, I mean, if you include test launches, then you could probably count all kinds of things as test launches. So I would just be curious, what the source is of that that Bloom put in. But I think in general, what you're going to want to use it for isn't something like factual like that. And you can see that when we go into detail. It's really going to be more of a sentence completion, generating content, that type of thing. In fact, if you take a look at the actual details on the Bloom page, one of the things that you'll see is they specifically recommend, under the risks and limitations, that they note that it can make errors, including producing incorrect information as if it were factual. And so it really is not intended to be used. And you can see they sort of talk about this in the uses. It's not intended to be used for anything that is a high stakes setting, as they refer to it here. And in particular, finance, politics, legal, biomedical, used for scoring individuals' employment, education, or credit, or using critical automatic decisions, generating factual content, creating reliable summaries, or generating predictions that must be correct. So that's pretty cut and dry about what the credibility is and the ability for it to be, really, really accurate is. It's relatively low, but it's still pretty interesting. And here you can see, okay, it looks like this was trying to run and it just stopped at some point on the server. And I don't know if this is a Bloom thing or if it's just an issue with this interface. So, all right. And then I also ran this on GPT-2, and I wanted to show you that as well. So let me see if I can quick find that. Okay, so I just generated this, and you can see what the answer from GPT-2 is on how many Skittles fit into a 747 jet. And we will ask it the same question on how many rockets has SpaceX launched. Okay, so you can see that it sort of didn't really answer the question properly. It has been pretty consistent in its launch schedules to do so. So that's kind of a different flavor of response that you're getting from GPT-2. Obviously, that's just a really specific scenario. So I don't want to try to say that it's not as good or anything like that. But obviously, with less data that it's based off of and been trained on, and less parameters, it's probably going to have a less optimized response to things like that. But I thought it was pretty cool how at least the Bloom AI came up with a pretty intelligent answer here that was pretty clever. And just really impressive how it is able to complete sentences and come up with pretty reasonable responses and thought processes. This was pretty cool that it literally responded and said, with improvements in digital fabrication, we expect rockets to be far cheaper and cheaper, and it will be a gradual process. And it's really able to draw on a lot of the content that it's read and been trained on, which is really, really cool. Okay, so now just doing a deep dive into the actual Bloom AI. One of the best places to go to do this is to just go to the huggingface.co/BigScience/Bloom. And then you can dive in here and see the same similar details that we've seen earlier, but in a little bit more granularity. You can dig into the basics around Bloom AI. And so here you can see it was developed by BigScience. You can go to their website. All collaborators are either volunteers or have an agreement with their employer. So in other words, this is meant to sort of help with the legal side of it, with making sure that this is open source, etc. The model type is a transformer-based language model. So really keeping in mind that it is a language model. Checkpoints format, transformers, and it's using the Megatron-Deepspeed format. And if you're interested in it, I recommend taking a look at this in detail. It's pretty interesting. So you can actually go into detail and look at this and see exactly how this is set up. I won't go into this in incredible detail in this video, but it is pretty interesting to dig into this further. So you can go take a look at the Bloom optimizer states and sort of drill down into it. And in particular, you can go take a look at this Megatron-Deepspeed. And if you haven't looked at this yet, this is pretty interesting. So it's a fork of Megatron-LM and Megatron-Deepspeed. And basically, it's a detached fork, and it integrates DeepSpeed into the original Megatron-LM code. And then basically, it's meant for, I believe it was actually meant for this project. It may be used on other projects as well, it looks like. But here, they actually walk you through the steps to set this up, which is pretty cool. So you can actually go through the steps to install Megatron-Deepspeed. And you can go through and complete the steps. Overall, they talk about the usage after that, and then actually how to go through and complete some of the different training. And this is pretty interesting because they really get into some detail here on how to go through and deal with issues, sort of like configuration and setup. So if you're interested in doing this and leveraging this, you have a really nice set of resources here that you can dive into. And actually get into the weeds on how this all works. So yeah, that's the checkpoints format. This is version 1.0.0. And you can take a look at the training data for Bloom. This is just further down the page. But one of the interesting things about the training data is it does have a lot of code, and relative to some of the other platforms out there, it does have a substantial amount of code that they've incorporated. So that's just going to be a really interesting use case. And they also have a lot more languages and coverage of those languages, which is also really interesting. Each of the dataset details are available in the DataCards section, which that is pretty interesting. So if you take a look at the actual data itself, here you can actually see some of the different data that's being used, and you can sort of like drill down into it and get access to where it is. So here they're using Stack Exchange for some of the code examples, and they are also using GitHub NoGPL. So this is a specific licensing piece where they're just trying to make sure that they're only using GitHub with the NoGPL. And then if you look at the different languages, you can see some of the different sources. So they have Semantic Scholar Open Research Corpus, and you can actually drill in and see the JSON for this. And these are just the settings to pull that data essentially. But you can actually look at all the different sets of data and just go through and look at all of those. So anyway, this is really helpful to sort of understand what the languages are and what the training data set was. They go over their licenses, the release date. You can actually send questions in. And then basically you can see some of the citations. So BigScience, or how you're supposed to cite this: BigScience language, open science, open access, multilingual language model. And that's the acronym. So BigScience language, open science, open access, multilingual is what the Bloom acronym stands for, and then language model. It has been funded by the French government, Hugging Face, and organizations of contributors, which they are going to provide. But really cool that the French government with their supercomputer and then the Hugging Face team really helped fund this. Very, very excited about it. Anyway, that's some of the high level of the Bloom open source AI. Now let's dive into the technical specs. So here you can see on the technical specs, you can read the Bloom training ReadMe and get a lot of detail. So this is pretty exciting. You can actually see some of the different nuances of how to go in and essentially calculate what's left for the training, for example. You can go in and see some of the different sort of dependencies, the data sets, the hardware that they used, the software. So we went over Megatron-Deepspeed. Then there's DeepSpeed, PyTorch, and Apex. And these are pretty standard for a lot of folks. But basically, those are the main aspects that they used. And of course, with any major set of testing with this type of hardware, there's all kinds of nuance to it. So they kind of go into that and talk about that here. But they actually have detail on launching this environment, which is really, really cool. So it's an actual script that they use to launch the environment. And then, I mean, I just think this is really, really helpful to learn from. They also have their full environment set up. So they go into this in quite a bit of detail. And it's detailed enough that I think, you generally would be able to benefit from it. They talk about crashes and how to deal with that, maintenance. So this is pretty helpful, actually, to be able to see how to replicate this environment. And let me just start from the top here and kind of work my way down. So again, if you kind of get past the environment and the model setup, then they go into their architecture and some of the different concepts here. So they have this replica concept that they're going into, optimizer, positional encoding. I mean, there's a lot of detail that you would need to go into to replicate this environment, but you could, and they've given a lot of detail on how to do it. And they're even citing some external resources. Like in this case, they're citing Facebook, which is pretty cool, and some of what Facebook's been doing. Then they go into the model architecture and objectives. So it's modified from Megatron-LM GPT-2. And again, you can go in and take a look at the paper, the research paper here, and then the Bloom Megatron code. So this is pretty interesting, just looking at sort of this overview of what's included, and then you can actually get into this research paper. So I think this is really, really cool. So you have access to it, and you can download the research. And let's see if we can get this to load. Yep. Okay, so you can actually go in and take a look at of course, the abstract that we were just looking at there, but then also just go into the research and just sort of understand the mechanics behind it. I find this really, really helpful, really give you a solid baseline, of course, for what you're working with, and just understand sort of many of the main concepts. So they go into that in quite a bit of detail here. They even go into the training and the setup, which is really helpful. Some of the different experiments that they ran. Yeah, and then basically tons of references that are really helpful as well. So if you are looking to replicate this this model, and you can see I'm downloading this, but if you are looking to replicate this model, you can, and it's obviously requires a lot of hardware. But there's a lot that you can learn by just going through some of the steps. Even if you obviously don't have a supercomputer just sitting around at home, you can still learn a lot by replicating a lot of these steps and kind of going through the process. It is a decoder-only architecture, layer normalization applied to word embeddings. Again, you can sort of go into the different code and papers. And I really like to go into these and look at them and really get into the weeds. And so here again, you can see this is the BitsAndBytes example. And they're talking about sort of a nuance, pretty important optimizations though. So they're talking about this layer normalization applied to word embeddings layer. Then the alibi, positional encodings, 176 billion parameters, 70 layers, 112 attention heads. And then hidden layers are 14,336 dimensional, the sequence length of 2,048 tokens. And here you can see the Bloom tokenizer, which let's see if that's actually correctly linked. It may just be a placeholder, it looks like. Okay, it looks like that still needs to be linked up possibly, or is just a placeholder for now. And then the objective function is a cross entropy with mean reduction. And so again, you can drill down into this. And this is pretty cool because you can actually get into this PyTorch set of classes that they're using, which I thought was really interesting. You can actually get into the math and sort of see, detail around how PyTorch is doing this, some of the parameters, and then drill into those. This is how they're doing it, and this is how this big AI is getting trained. So what are some of these very talented researchers doing, and how can you replicate it? How can you sort of benefit from it with your AI and machine learning work? Or if you're not actually doing the work directly, like what is possible in a reasonable amount of time if you're sort of trying to understand this from the perspective of what can be done in a reasonable amount of time. Again, the compute infrastructure was I'm probably not pronouncing this properly, but Gene's a public supercomputer provided by the French government. And here you can see the hardware, which I know some of you watching are, you have better hardware sitting around at home, but this is what the French government was able to come up with. All joking aside, it's pretty incredible. 384 A100s, 80 gigabyte GPUs, which is incredible. So, and then an additional 32 in reserve, 8 GPUs per node, and they just go in. I won't bore you with the details, but they go into all of the setup here. But one of the big things with AI is the way that the actual hardware is physically set up, so that you can optimize a lot of the matrix math that's going on, that is very different than typical compute that you would otherwise do on a machine. Whenever you're doing training, it's very matrix math oriented and very systematic in that way. So setting up the hardware and having hardware that's optimized for AI can be multiple orders of magnitude improvement in performance for the same set of training that needs to occur. So definitely very important if you're looking to actually replicate some of this training. And then they provide links to everything. We went over each of these earlier, but they actually provide the links so you can go and drill in. Megatron-Deepspeed, of course, is really specific to this project, but they also provide links to DeepSpeed, PyTorch, and Apex. Okay, next let's take a look at the training section. So in the training section, you can see they provide a really helpful sort of set of links. And we went over a little bit of this earlier, but you can see they have the data cards, and then they also have an interactive Corpus map, which is pretty cool. So you can see just a visual of the actual training. Yeah, it's pretty self-explanatory. But you can see there's quite a bit of code here that they're actually doing, they're providing, and you can drill into this, which is pretty cool. So we can look at the GitHub and then sort of go back out, go into the different languages, drill back out, and you get the idea. So pretty cool, pretty interesting. Anyway, 13 different programming languages in addition to 46 natural languages, 1.6 terabytes of pre-processed text, converted into 350 billion unique tokens. And you can take a look at the tokenizer to see. I think that one's just not linked up yet properly. It may be because on this page that I'm on, you can see that this UI brings the text example that I put in. It brings it into the query string. Let me try getting rid of that and see if it allows me to jump to the tokenizer section. Yeah, I think that's just not possibly jumping to the right place, or maybe I'm already on the tokenizer section here. languages. You can see a visual of that. And then you can also see the percentages of the languages. And I'll just zoom this in some. So pretty small percentage relative to the full data set for some of these, but a lot of representation that wasn't there and isn't there in other AI platforms, which is really cool for research. And then you can see the programming language: Java, PHP, C++, Python, JavaScript, C#, Ruby, etc. So these are pretty interesting. If you want to go do some testing, you can. And they've got the different versions of the languages too, which is sort of interesting if you think about it. Being able to delineate between the language versions for a AI that's got these different parameters and weights that it's trying to achieve. Definitely interesting to research that. Then they talk about pre-processing. So so this is where the tokenization link is supposed to take us. The Bloom tokenizer is a learned subword tokenizer trained using a byte level byte pair encoding BPE algorithm, a simple pre-tokenization rule, no normalization, and a vocab size of 250,680. It was trained on a subset of preliminary version of the corpus using alpha weighting per language. So again, this looks like it's sort of a placeholder for now. And then you can actually look at the speeds, sizes, and times. You can look at the training logs, which is pretty exciting to check out. So you can actually see the different batches and the training results. Yeah, this is really cool. So you can actually drill down into this, look at the learning rate, and you can see there was a pretty substantial spike there in some of this data, which is always fun to deal with. And yeah, you can just see some of the different ways of visualizing this training. Really, really, really cool. Okay, so anyway, if you go back, again, you can see the training started for this data set that they're showing 11th of March, 2022, ended the 5th of July, 2022. And it was just one epoch, which is interesting. So they're thinking that the cost of all of this training was about $2 to $5 million, which relative to the value of this, I mean, it's easy for me to say, but doesn't seem that bad. Okay, now let's take a look at some of the uses. So in order to use the Hugging Face ecosystem, you basically create a account, and then you can bring in this Bloom model. You can do it programmatically, as we're showing here. It needs transformers and accelerate installed. So there's just an example here that they're showing on the site. Eventually, you would be able to, if you set up a environment that can handle it, you could actually download it and use it locally too. But for now, you can go to the Hugging Face site and basically put this code in, or you could alternatively just use their interface to test it and play with it in that simple interface. But if you wanted to programmatically test it, this is how you can do that. The model is being created in order to enable public research on large language models. They're intended for language generation or as a pre-trained base model that can be further fine-tuned for specific tasks. So basically text generation and then exploring characteristics of language generated by a language model. So this would include closed tests, counterfactuals, generations with reframings. And I think in general, the idea here is to look at some of the biases and some of the issues that you're going to find with pre-trained model that you can then further fine tune, and some of the issues that occur and how to optimize that, as well as just general large language model for text generation. So pretty interesting downstream usage that they're talking about here are information extraction, question answering, and summarization. And then they go into misuse and out of scope use. There is a Bloom license, and you'll want to make sure that, to the extent that you're using this, that you go in detail and read this, and that you understand and you're complying with their license. But basically, one of the biggest things is just that it doesn't get abused and it isn't used for harm or creating spam, essentially. Using the model in high stakes is out of scope, and it's not designed for critical decisions. And it literally says, nor any uses with material consequences on an individual's livelihood or well-being. So they are very clearly calling that out. Biomedical, political, and legal, finance, scoring individuals, such as for employment, education, or credit, or applying the model for critical automatic decisions, generating factual content, creating reliable summaries, or generating predictions that must be correct. So they're actually saying that it is a misuse to do things like the following. So using the model for harm, obviously violating human rights or other kinds of malicious activities, but that includes spam generation, disinformation and influence, disparagement and defamation, harassment and abuse, deception, unconsented impersonation and imitation, unconsented surveillance, and generating content without attribution to the model as specified in the rail license. So that's pretty interesting too. So if you are going to generate content with this, you have to provide attribution to the model. And that could, for a lot of folks, defeat the purpose of using an AI, because a lot of folks are going to generate content and try to make it seem like someone generated that as a human, and then get it so that it can be searchable, etc., and beneficial commercially to their business, for example. Intended users, general public, researchers, students, educators, engineers, and developers, non-commercial entities, and community advocates, including human and civil rights groups. Indirect users are users of derivatives created by direct users, and then users of derivatives of the model. And basically, they're saying it's not really meant for commercial use, and it's specifically meant for research, maybe software developers, educators, students, so they can sort of experiment with it, but really non-commercial activities. Let's take a look at the risks and limitations. And we sort of went into this with the uses, but the model may over-represent some viewpoints and under-represent others, contain stereotypes. And this is one of the main reasons why Bloom came out, among others, was sort of to be able to look at this and research it and understand how we can sort of mitigate stereotypes and over-representation with the large language training process and with the weighting and the different essential outputs that we want to get that should be more optimized versus what we see in a lot of the research that's going on. It may actually contain personal information, they're saying. It may generate hateful, abusive, or violent language, discriminatory or prejudicial language, content that may not be appropriate for all settings, make errors, including producing incorrect information as if it were factual, generate irrelevant or repetitive outputs, or induce users into attributing human traits to it, such as sentience or consciousness. Maybe. I think that's a pretty big reach, but maybe if it's done in the right way. But yeah, anyway, the point is that they're just putting major disclaimer out there. They talk about the evaluation and the perplexity and the cross-entropy loss. So they basically are going into some of the different factors behind, why they chose these metrics of perplexity and cross-entropy loss. And then basically this section lists some different aspects of the Bloom models, language such as English or Yoruba, domains such as newswire or stories, demographic characteristics such as gender or nationality. And so you can sort of see, they are saying these are intermediate results. And then essentially, if you go in and you look at this, you can see some of the different, basically, it looks like they're comparing Bloom 176 to Opt 175, and they're showing this set of metrics that have been met. So for the different languages and the different data sets, what are those results? Just quickly scroll through those. Some of the recommendations that they make are indirect users should be made aware when the content they're working with is creating by the large language model. Users should be aware of risks and limitations. Models trained or fine-tuned downstream of Bloom should include an updated model card, and users of models should provide mechanisms for those affected to provide feedback. And then the glossary, they go into some of the different terms, which is really helpful if you're not familiar with some of these. You can sort of read the summary. And then they have a set of additional data. Definitely a lot of really helpful information. So they published intermediate checkpoints, which is really cool. So you can actually get access to that. So that's pretty interesting. And you can sort of see what's going on in intermediate to the complete training being done. The data set creation, the different tech specs, and sort of more detail that they go into on how to set all of this up. So if you're really looking to do something at this scale, this is going to be really, really helpful. They actually go into some of their lessons learned, which I think is really, really, really helpful. Sort of like a summary, how training divergences were overcome, adding some of the nuances of what they figured out, instabilities. I mean, this is some of the blood, sweat, and tears knowledge that the team learned and they've summarized. So if you're looking to do something similar, or understand how to solve problems if you're working with AI and machine learning, this can be quite helpful to get into. Okay, and then they go into some of the different model card authors as well. We certainly hope that that was a helpful overview of the Bloom open source AI. I am so excited to get to dig into this and continue working with it. There are a lot of opportunities for us to continue experimenting and learning more. And we'd love to hear from you about areas that you would like to see as we continue to dig in and learn more about this. Thanks again for watching, and bye for now.